live from Santa Cruz, California. Our topic for the day is climate variability and why you should care in order to be prepared for the future. First, we have Nikki, who's reporting on the El Niño Southern Oscillation. Let's have a look.
El Niño Southern Oscillation occurs in the tropical Pacific Ocean every 3 to 7 years. When the trade winds across the equator slow or reverse, also known as the Walker Cell, and the water temperature in the West Pacific becomes warm with high atmospheric pressure, it is referred to as El Niño. When water temperature becomes cold with low atmospheric pressure, it is referred to as La Niña. During El Niño, weather conditions in the east become wet and in the west, dry. In addition, the Southern Oscillation Index becomes negative. During La Niña, the reverse happens. Normal conditions are enhanced, and the Southern Oscillation Index is very positive. During the 2010 El Niño event, the Caramaguanas Reef was observed and its effects were recorded in order to prove that El Niño events affect coral reef bleaching. As water temperatures change and become cooler because of ENSO, coral reefs become stressed and expel their zooanthellae, which identifies the coral's pigmentation. The coral then becomes lighter in color due to the many stresses it endures. A biological response that resulted from both the 1997-98 and 2009-2010 El Niño events was a reduction of chlorophyll A. Chlorophyll A is a photosynthetic pigment that is necessary for most ocean plant photosynthesis. Productivity in the equatorial Pacific is significantly affected due to the reconstruction of the marine ecosystem and alteration of the equatorial Pacific carbon cycle because of this loss of chlorophyll A. It was reported that in the eastern equatorial Pacific, chlorophyll A was reduced. In the western equatorial Pacific, there was an increased amount. El Niño events cause upwelling along coasts that brings nutrients to the surface, which salmon feed upon. Salmon begin their lives in rivers and gradually move out towards the ocean during the middle stages of their lives. As the water temperatures change, however, organisms and other fish begin to migrate north following the warm water. This creates a feeding ground for them in which salmon is present. This significantly decreases the salmon population. The El Niño Southern Oscillation is a variable for climate change that affects the entire globe. As citizens of future generations, the more we know about El Niño and La Niña cycles, the better we can understand our changing climate system and will be better able to predict future events and prepare accordingly. Thank you. Back to you, Susie.
Thank you, Nikki. Other oscillations that affect our climate are the North Pacific Gyre Oscillation and the Pacific Decadal Oscillation. Let's talk with climate scientist Fred Reed. Fred?
Thanks, Susie. Climate oscillations are recurring climate patterns that have fluctuations in atmospheric temperature, sea surface temperature, and precipitation. The PDO is the first mode of sea surface temperature anomalies that occurs in the Pacific. Forced by E and SO, the PDO demonstrates a positive phase where the West Pacific becomes cool and the Eastern Ocean warms. Sharing similar patterns, the PDO strongly influences multi-decadal droughts in northern U.S. during the positive phase and droughts in the southwest during the negative phase. Asian monsoons are also increased during the negative phase of the PDO. The PDO is forced by ENSO and an Eastern Pacific warming with the Allenton Low. The AL is the low pressure zone over Alaska that affects atmospheric pressure throughout the Pacific. The MPGO is the oceanic response to atmospheric forcings associated with the North Pacific Oscillation. The North Pacific Gyre associated with the MPGO is a combination of 5 ocean currents that transfer heat, nutrients, and sustain other ecosystems' life, such as fisheries around Alaska, the California coast, or phytoplankton communities throughout the Pacific Ocean. Some oceanic responses to low-frequency fluctuations include a weakening of the Walker Cell that affects normal gyre conditions. Along the coast, forced PDO and MPGO control change in upwelling cells, causing abnormal responses to coastal upwelling. Although both forced by ENSO, the PDO and MPGO have their own unique physical changes. Using satellite-driven data from 1993 to 2005 of the PDO and MPGO's sea surface temperature spatial pattern, revealed that the MPGO amplitude was higher than the PDO's than in previous years. The strengthening of the MPGO in 1993 may represent a response to anthropogenic forcings and global warming. The PDO and MPGO are key variables to keep in mind when making predictions on future weather anomalies throughout the Pacific Ocean.
Thanks, Fred. Now, all of you who find clouds interesting, brace yourselves. We have been so lucky to bring in a special guest to talk to you about the Madden-Julian Oscillation. Please welcome Ian the Cloud.
Thanks, Susie. Now, a lot of you might be asking, what is the Madden-Julian Oscillation? Well, I'm here to tell you. The Madden-Julian Oscillation is a cluster of clouds that propagate eastward starting from the Indian Ocean, making its way over to the East Pacific Ocean. MJO forms in the Indian Ocean due to an increase in the sea surface temperature. The rise of the sea surface temperature causes a convection cell, which appears to form a massive cloud cluster in the equatorial regions. Madden-Julian Oscillation occurs every 30 to 60 days. Now that you know the basic science behind the Madden-Julian Oscillation, let me tell you a little bit about the effects of it. Madden-Julian Oscillation is one of the main factors in climate variability in the tropical and subtropical regions. Along the equator, the cloud clusters follow the warm sea surface as it travels in the westward direction. The cloud clusters leave a colder sea surface temperature and a weaker convection state in their path, interrupting rain patterns in the tropics. When the tropical rainfall reaches the central and western Pacific Ocean, increased rainfall can occur as high as the Pacific Northwest. This is caused by a circular wind pattern going from the central Pacific to the northwest coast of North America. It is pulled away from the coast in an eastward-bound direction with winds near the tropics. Let me tell you a little bit about the waves associated with the Madden-Julian Oscillation. The Rossby wave is a wave that propagates warm surface water to the west. Warm surface water is crucial to the Madden-Julian Oscillation forming its cloud clusters, and since the Rossby wave moves warm water to the west, it follows that the cloud clusters also move to the west. Enough about Rossby waves, though. Let's talk about Kelvin waves. Kelvin waves are waves that balance out the Earth's Coriolis effect. Since the Madden-Julian Oscillation leaves a weaker convection cell in its path, it allows water that is being pushed to the east coast to flow towards the west. Since we're talking about Kelvin waves, I'd also like to talk about El Niños. Along with interacting with these waves, Madden-Julian Oscillation has an impact on other oscillation phenomena too. The Kelvin wave that is created by the Madden-Julian Oscillation flattens the tilted thermocline, providing conditions that are optimal for an El Niño to occur. This isn't to say that Madden-Julian Oscillation causes El Niños, but it can increase the speed at which they develop, as well as the intensity. The Madden-Julian Oscillation, as I have just explained to you, has a large effect on climate oscillation on a global scale. But with global temperatures on the rise, the Madden-Julian Oscillation shall occur more often, but with a weaker intensity. This could dramatically change the ecosystem of the tropical regions along the equator, turning already wet atmosphere into areas of year-long rainfall. That's all I have to say about the Madden-Julian Oscillation for today. Thanks for having me, Susie.
Wow, thank you, Ian the Cloud. That's very interesting stuff you brought up. For our final segment on today's show, please welcome Noel, a researcher of monsoons in the Indian Ocean. Noel?
Thanks, Susie. Monsoons are a seasonal wind that causes large amounts of rainfall, mainly in India and Southeast Asia. They occur in both the winter and the summer, but mostly in the summer. This is because formation of monsoons depend heavily on the heating of the landmass from solar radiation. During May and June, the land is heated a lot, causing many droughts and creating a low pressure system. A cool high pressure wind from the southwest gets stronger, collecting moist air ready to fall once it is warmed over land. Because the water comes from the Indian Ocean, monsoons can occur throughout the year, depending on the wind movement. Normally, the equatorial trade winds blow from east to west. When these winds weaken, the Somali jet stream picks up this wind and pushes it towards the hot southwest region of India. This is similar to the formation of monsoons in West Africa and in the East Indian Ocean. The Madden-Julian Oscillation affects the Australian monsoons the most. The probability of extreme rainy weather triples in the west phase of MJO. More tropical cyclones form. Researchers have found El Niño's relation to the Southeast Asian monsoons to be the opposite. There has never been an excess rainfall during El Niño in this region. 9 of the 17 El Niño events in history led to a drought in India and Pakistan. The most recent was in 2009, when India saw a 33% shortfall in rains during the monsoon. People, crops, and wildlife of these regions heavily depend on this rainfall. Monsoons consist of 90% of West India's annual rainfall. If droughts continue, soil erosion will make farms unusable. With rainfall expected to be lower than normal in this monsoon season, any rainfall from tropical cyclones would be increasingly important.
Thanks, Noel. Best of luck to all of you in Southeast Asia. We here at TCMG News would like to thank all of our special guests who joined us today to speak about climate variability. Have a good night.